Okay, we're going to take a look at Chapter 8. We need to find out which values this is undefined, so we have to think about when the denominator would equal 0. That's really the question that's being asked. When does the denominator equal 0? So it becomes a factoring problem. Looks like we're going to need to put our 2 here and our 1 here. That would make I need it to be a negative 4x and a positive x. That way they add to negative 3x. So then if we set each of those equal to 0, we would get x is negative 1/2 and x is positive 2. Negative 1/2, positive 2, that's b. Number 2, we're going to go ahead and factor each numerator denominator. So t minus 3, t plus 1. T plus 1, t minus 1. Over here I factor 3 out, giving me t minus 1. And then down here, t minus 1 and t minus 3. So let's see what we can cancel out. T minus 1s can cancel. T minus 3s can cancel. T plus 1 can cancel. All I have left in the numerator is 3, and then in the denominator t minus 1. So 3 over t minus 1 is j. Alright, here nothing factors out of that first numerator. Number 6. Change it from a division problem into a multiplication problem. So 10 goes in the numerator. This is a difference of 2 squares, so this does factor. M plus 2f, m minus 2f. And now I have an m plus 2f that cancels out of the top and the bottom. 10 and 6 can both be divided by 2. So now I have 5 over 3 times m minus 2f. That's a. Here we have to add, so we need a common denominator. Think of this first denominator as m plus 5, m minus 5. So that is going to be the least common denominator. So the first fraction can stay the same. Second fraction's got to change. We already had the m minus 5, so I have to introduce an m plus 5. So if I'm multiplying that denominator by m plus 5, I have to multiply the numerator by m plus 5 also. Distribute, I get 3m plus 15. Now add. 3m plus 45 becomes my numerator. Let's look at that numerator, see if we can factor. I can pull a 3 out. And I don't think anything cancels, so I get 3 times m plus 15 over m plus 5, m minus 5, that's j. Alright, let's go. To the next question, number 5. Notice your denominators are very similar, but not quite the same. That second denominator, if I switch the order, I get negative m plus 6. And I want the same denominator, so I'm actually going to factor a negative out of that denominator to make it m minus 6. When we pull a negative out of both of those, that turns it into a plus in between, because it was subtraction. I just factored out a negative. Negative, negative is positive. Okay, so now I have 7 plus m, or m plus 7, over my common denominator. Looks like that's b. Number 6, determining vertical asymptotes. So vertical asymptotes happen when there's holes in the domain. So we have to set our denominator equal to 0 to find any vertical asymptote. So we're going to have to factor that. X plus 3, x minus 1. So that means that x has to be negative 3 and positive 1 to make vertical asymptotes. So at negative 3, at positive 1, I have vertical asymptotes. That's h. Number 7. Really, to determine which one of these is graphed, I'm going to look for those asymptotes. I see I have an asymptote at 1 and an asymptote at -3. So 1 and -3. So A is not good enough. That only had 1. B has a -1. That's not it at all. I can throw that out. C would have a +1 and a -3. C looks like a good option. Let's check out D. It'll be a +3 and a -1, and that's switched. I don't want a +3 and a -1. So C is the only one that has those asymptotes, so it must be the right answer just by process of elimination. All right, now we get into lots of variation problems. Way too many. There's only one on the test, but lots of them on this worksheet. But here we go. Y varies jointly as. I don't have a lot of room to work here. But I'm going to say y1 over, and if it's jointly, that's the same as direct. Put x1 in the denominator and z1. And then that will equal y2 over x2 z2. So let's start plugging in numbers. So y equals 60 when x and z are those, so plug those in. 60 over 10 times -3 equals, then we're trying to find y. X is 8, z is 15. Let's do a little simplifying here. 10 times -3 is -30. 60 divided by -30 is -2. Equals y over 120. So multiplied by 120, we get -240. So F is the answer to number 8. Number 9. Varies directly. Sales vary directly. So sales, so you could say S1 varies directly with the amount of money spent on advertising. Maybe I'll say A for advertising. So directly, S1 over A1 equals S2 over A2. Plug our numbers in. Sales were 10,000. Advertising was 2,000. So now we're trying to estimate what the sales will be when the advertising is 1,200. This 10,000 over 2,000 can simplify. First of all, I can drop 3 zeros off. So 10 over 2 is 5. So 5 equals S over 1,200. So we would take 1,200 times 5 to get 6,000 B. Number 10 rather. Y varies inversely. So instead of y over, it's going to be y times x1. If it's inversely, they're going to actually get multiplied together. Equals y2 x2. Plug your numbers in. So y was 5 when x was 5, so 5 times 5 equals, and now we're looking for y when x was 45. So 5 times 5 is 25, so we have 25 equals 45y. We would divide by 45. Divide and multiply by 5, so 5 over 9. So 5/9 would be our answer. That's H. Number 10 was H. 11. Distance. So D1. Car can travel in a certain amount of fuel varies inversely. Okay, times. So since it's inversely, I'm going to multiply it times speed. So S1. D1 times S1 is going to then equal D2 S2. Plug numbers in. Car traveling 50 miles per hour. So that would be our speed. 336 would be our distance. 336 times 50. And notice it says on 10 gallons of fuel. That is a little bit of extra. It's not necessarily extra information, but it can throw you off. That doesn't go into our formula anywhere. It was saying up above that it's talking about a certain amount of fuel. So what we want to do is just make sure that in the second case we have the same amount of fuel. It says 10 gallons, so 10 gallons, 10 gallons. That just means they're the same amount. Good. I can go ahead with the problem, but we ignore the 10. So now how far? So we're looking for the distance when the speed is 60. So I'm going to take the 330. I'll just divide by 60. 336 times 50 divided by 60, and I get 280 miles. That would be D. Number 12. They're asking, hey, does this represent direct joint or inverse. There is no such thing as combined variation, so we can throw that out. Joint means that there's at least 3 variables. We don't have that, so we can throw out joint, so it's either direct or it's inverse. So if I wrote it in the way I've been writing the other problems, I put both variables on the same side, like if I divided by z, we'd have y over z, and so hopefully that then indicates to you that it's direct. If we put them on separate sides, like as in this equation, as long as neither one's in a denominator, that's a direct variation problem. So that's what I see here. So we should recognize in one way or the other that that is a direct variation problem. So then 13 looks very similar. There's no denominator, and the variables are on the opposite sides. So it's direct, except there's multivariable, so that makes it joint. So this is a B. All right, number 14. Here we have an addition or an equation. I would multiply by the least common denominator, which is n minus 3. So I'm going to multiply both sides of the equation by n minus 3. So we'll have to distribute on the left side. First of all, when you take n minus 3 times that first fraction, the n minus 3 in the denominator and what you're multiplying by will cancel. You'll be left with n. Then when you distribute it to n, nothing cancels. So you have to take n times n minus 3, giving us n squared minus 3n. Then we get our equal sign. On the other side, my n minus 3's cancel, leaves me with 7n minus 18. So right now, if I combine like terms, I get this. I want to set it all equal to 0, so bring everything to one side. So n squared minus 9n plus 18 is equal to 0. N minus 3 and n minus 6. So n is equal to 3, and n is equal to 6. But notice if you plug 3 in to the problem, it makes your denominator 0, so that's not part of our domain. We have to throw that out. There's an asymptote there. So 6 is the only answer for this problem, so that's G. So be careful. That one looked like it was going to have H for an answer, but you had to check your answers and notice that that didn't work. Okay, number 15, very similar. It's an inequality, but I'm going to do the same process. I'll multiply both sides by my least common denominator, which is m. Distribute on the left side, 7m minus, then my m's cancel, so I get 3 is greater than. Over here the m's cancel, I get 18. I'm going to add 3 to both sides. Divide by 7. M is greater than 3, C. Except, hold on, I got ahead of myself. That's part of it. But it actually, if I break this down and think about as I evaluate these other answers, notice they're also talking about zeros. Maybe I should at least consider, do I want to think about 0? Since it's an inequality, that may be the case. Think about if we had a number less than 0. We know m is greater than 3 is going to work. Let's think about a number less than 0. If it's less than 0, it's negative. If I plug that in there, a negative number for m, think about what's going to happen. 7's positive. Negative 3 divided by a negative number, negative over negative will be positive. That's going to be plus. So 7 plus a number, that's going to be a positive number. I'll have a positive on the left side. Think about the right side. If you have an m that's negative, 18 over negative, that's going to be a negative number. I don't care what the numbers are. Positive will always be greater than negative. So if you have something less than 0, it's also going to work. So not only does it work when m is greater than 3, it also works when m is less than 0. So we're going to have A for our answer here. We might not have caught that. Remember on the inequality problem, sometimes there's other things we have to consider. So this is where it's helpful to have a multiple choice problem, so we at least knew, hey, I probably should think about 0. If you didn't know what you were supposed to do initially, we at least seems to indicate that 0 might be involved. It's worth checking out. And in this case, we find out that, yeah, we did need m less than 0 also. All right, and that's the end of Chapter 8.